there are going to be 5 basic organic reactions that we're going to look at. The first is combustion. We've seen those before, but we'll consider complete and incomplete combustion reactions. The second, third, fourth, and fifth will be new. So the second type will be addition reactions, where we have 2 reactants that are going to combine together to form one product. Second is going to be substitution reactions. The third are going to be elimination reactions, which you'll see are essentially the reverse of an addition reaction, at least at the level that we're looking at them here. And the fifth are going to be esterification reactions, where we're going to form a new functional group called esters. And we'll look at those at the very, very end because they're brand new. Combustion reactions. So in a complete combustion reaction, what you have is a fuel. In this case, it's going to be a hydrocarbon. So this molecule will contain only carbon and hydrogen atoms in some ratio. And it's going to react with oxygen. Now we will always get the same products. We'll get carbon dioxide and we'll get water vapor as our chemical products. And when we have an excess of oxygen, we have enough oxygen here, then we will get complete combustion. We will get incomplete combustion when we don't have enough oxygen to fully react, to fully combust the hydrocarbon. And in this case, we're going to get carbon monoxide instead of carbon dioxide. We do incomplete combustion. And it's incomplete combustion that you have to be worried about, really especially worried about happening in an enclosed space, because it can produce carbon monoxide, which is highly toxic. It displaces the oxygen off of your red blood cells, off of the hemoglobin in your red blood cells, and it binds to it more tightly than the oxygen. And so even though you're breathing in oxygen, it limits the amount of oxygen that can actually make it out to your cells. So what would these look like? Let's take a basic hydrocarbon like propane, C3H8. So you have propane in your barbecue maybe. It's a gas. It's going to react with oxygen. And we have an excess in this case to produce carbon dioxide gas and water vapor. Now we need to balance this reaction. We've got 3 carbons over here, so we need a 3 over here. We've got 8 hydrogens over here. 4 times 2 is 8, and then let's count up our oxygens. We've got 6 here, plus another 4 is 10, and 5 times 2 will give us 10. So now this guy is balanced. If we react propane with insufficient oxygen, there will still be some oxygen involved, so it's still a reactant, but there's not enough. So as it reacts, instead of producing carbon dioxide, it will produce carbon monoxide gas and water vapor. Now we can balance this guy too. We've got 3 carbons here, so we've got 3 here. We've got 8 hydrogens. 4 times 2 is 8. And let's see about our oxygens. We've got 4, 5, 6, 7. And oxygen comes here in groups of 2. Now when we get to our next unit, we'll actually start allowing you to balance with fractional coefficients. So you could balance this with a 3.5, but what we would have taught you before would have been to double all of the coefficients you have. So we're going to double this, double this, double this. So this would become a 1. This 3 is going to become a 6. This 4 is going to become an 8. And now instead of 7 oxygens, I'm going to have 14. Got 8 plus another 6, and that is divisible by 2. So that gives us a 7 here. And remember that balancing trick. Anytime you have an odd number of oxygens on one side, if you double, that will allow you to place a whole number coefficient. So here's an example to try. For dimethyl propane, write the balanced chemical equation for the complete combustion and for incomplete combustion to produce carbon monoxide. So we're going to try both of these here. I'm going to pause the video, and you should pause the video too. Try writing both of these guys out, and then play, and we can meet back up. Of course, one of the first things that you're going to have to do is to figure out what the chemical formula for dimethyl propane is. Okay, so I've got my 2 here. See if you agree with me. For my complete combustion, I've got my dimethyl propane, which is C5H12. It's reacting with oxygen to produce carbon dioxide and water, and I've got my balancing here. For my incomplete combustion, I've got my dimethyl propane reacting with oxygen. I get carbon monoxide instead of carbon dioxide, and I've got water as well. And then this one as well, I had to double my coefficients in order to make the balancing work. Now in reality, when a hydrocarbon reacts, both of these processes, complete and incomplete combustion, would be happening at the same time at some ratio. If you have a combustion apparatus that's able to burn very efficiently, so it means that it gets lots of oxygen to the flame. A gas stove is an example of this. It burns very efficiently. It's doing almost completely complete combustion, very little incomplete combustion, which is why it's safe to operate inside your house. But something like a propane barbecue isn't as efficient. It's not as good at providing just the right amount of oxygen to do complete combustion, which makes it unsafe to operate in your house. And then something like a wood-fueled fire, you have to vent the exhaust outside because there's lots of incomplete combustion happening in a wood fire. And as a result, you have lots of carbon monoxide that's going to be produced. And so then that means that it's very unsafe to have that happen inside. But, we have to kind of tell you what's going on. So in Chemistry 30, if you're not told otherwise, assume that if you just see us talking about combustion, we mean complete combustion. If it's incomplete combustion, we'll tell you, and often we will tell you as well that it's complete combustion.